If you're looking for somewhere quiet to rest your mind tonight, you've found it. This is nearly 90 minutes inside the Milky Way. No rush, no noise, just the slow, quiet science of the galaxy that holds you. Whenever you're ready, we'll begin. If nights like this help you rest, a like or a subscribe means more people find their way here too. One quiet soul at a time. There is a place you belong to. A place so large that no single human eye has ever taken it all in at once. A place older than the sun, older than the planets, older than most of what we tend to call ancient. And tonight, as you settle into wherever you are resting, we are going to travel through it together. Not quickly, not dramatically, just gently, the way light itself moves, forward and outward, and without any hurry at all. The place I am describing is the galaxy we call home, the Milky Way, a vast, slowly turning system of stars and gas and quiet darkness that has been spinning for more than 13 billion years. And somewhere within it, on a small blue world orbiting an unremarkable star, you are here, resting, breathing, part of it all. Let your body soften now. Let your shoulders drop. If there is any tension you have been carrying through the day, you can set it aside for a while. There is nothing you need to hold tonight. The galaxy will keep turning without your effort. The stars will remain in their slow orbits, and you can simply be here. We will move through this galaxy together over the next little while. There is no rush. Every idea we visit is simply a quiet doorway, something to let your mind rest upon before it grows softer, slower, and finally still. Begin then with something that might surprise you. The galaxy you live in is not finished. It is still growing. Even now, as old and vast as it already is, the Milky Way continues to pull things toward itself. Streams of gas drifting through the spaces between galaxies. Faint outlying clouds of hydrogen moving slowly inward. Smaller companion galaxies caught in its gravitational pull, their stars slowly unwinding into long, luminous threads. This growth is not violent most of the time. It is patient and slow, the way a river deepens its own bed over centuries. The Milky Way adds to itself the way all great things do, gradually, through the quiet accumulation of what comes close enough to stay. And so, the galaxy you live in today is slightly larger than it was a billion years ago. It will likely be larger still in a billion years to come. That is a kind of growing that requires no urgency, no rushing forward, only time and the steady pull of gravity, drawing things homeward. The galaxy is, in its simplest shape, a disk. A wide, flattened structure, something like a lens or a shallow plate, with a thicker central region at its heart, and thinner layers spreading outward to its edges. From its centre to its far rim measures somewhere around 100,000 light years. A light year, if you are not already familiar, is the distance that light travels in a single year. And light moves fast, nearly 300,000 kilometers every second. In 1 year, light covers approximately 9.5 trillion kilometers. 100,000 of those years worth of distance. That is how wide our home is. And yet even that number doesn't fully hold its size. Within that 100,000 light-year span, there are somewhere between 2 and 400 billion individual stars, perhaps more. The uncertainty itself is a kind of wonder, that something so vast can still hold so many unknowns. Between those stars stretch enormous clouds of gas and dust, regions of near complete emptiness, interrupted by ribbons of matter so cold and dense that stars are quietly assembling themselves within them, even now as you rest. Let me tell you something about how stars begin. Deep in the cold heart of a molecular cloud, a region of gas so thick and so chilled that light barely passes through, gravity begins its slow work. Over thousands of years, the gas compresses. It pulls toward its own center. As it does, it heats. The pressure builds. And eventually, if enough material has gathered, a threshold is crossed. Hydrogen atoms begin to fuse. Energy radiates outward, and a star is born. The process is gentle at its beginning, a slow accumulation, a quiet gathering, nothing like an explosion, more like a breath slowly deepening until suddenly the lungs are full. These stellar nurseries, and astronomers actually use that word, are scattered throughout the spiral arms of the Milky Way. Some are enormous, containing enough material to eventually form thousands of stars. Others are more modest. But in all of them, the same patient chemistry unfolds. Matter, drawn inward by gravity, heated by its own compression, until something new ignites. The Orion Nebula is one such nursery. It is visible to the naked eye on a clear winter night, a faint smudge of light in the sword of the hunter. But within it, hundreds of young stars are currently forming. Some have only recently crossed the threshold into fusion. Others are still in the process of gathering themselves from the cloud around them. When you look at that soft glow in the sky, you are looking at beginning, at the first light of stars that have not yet finished becoming what they will be. Our own star, the Sun, formed in such a nursery approximately 4.5 billion years ago. The cloud that gave it birth also gave rise to the planets, the moons, the asteroids, the comets. Everything in our solar system traces back to that same original cloud of gas and dust. The Sun is now in the middle of its life. It will continue fusing hydrogen for another 5 billion years or so. During that time, it will remain much as it is, warm, steady, and reliable. It is, by any measure, an ordinary star, medium in size, medium in temperature, positioned in an ordinary region of an ordinary spiral arm, about 26,000 light-years from the galactic center. And yet within that ordinariness, everything we know is possible. The warmth that keeps the oceans liquid, the light that drives the chemistry of every living thing, the gravity that holds the planets in their places, ordinary and extraordinary at once. The Sun is not, of course, sitting still. Nothing in the galaxy is. Our entire solar system, the Sun, the planets, the moons, all of it, is in motion, moving through the galaxy at roughly 828,000 kilometers per hour. That is a speed difficult to feel, because everything around us is also moving, and because the distances are so immense that even at that velocity, our position within the galaxy changes imperceptibly from one human lifetime to the next. At that speed, it takes approximately 225 million years to complete one full orbit around the center of the Milky Way. Astronomers call this period a galactic year. Since the solar system formed, we have completed only about 20 of these orbits. When the first of the great dinosaurs appeared, we were positioned in a completely different part of the galaxy than we are now. The sky would have held different neighboring stars, different clusters visible from Earth's surface. We move through a universe that is itself always rearranging. The constellations we see tonight are a temporary arrangement. In tens of thousands of years, they will have shifted. In millions, they will be unrecognizable. Everything moves. Everything changes. And yet, within that change, things persist. At the center of the Milky Way, there is something we cannot see. Not with ordinary light. Dust and gas fill the inner regions so densely that visible light from the galactic center never reaches us. Entire clouds lie between us and the core, absorbing and scattering the light of billions of stars before it can cross those last 26,000 light-years to our eyes. But infrared light moves through dust more easily, and radio waves pass through it almost entirely. And so, with instruments built to detect those longer wavelengths, astronomers have mapped what the visible cannot show. What they found at the very center is something called Sagittarius A star, a supermassive black hole, an object containing approximately 4 million times the mass of the Sun, compressed into a region smaller than our solar system. 4 million solar masses. in a space the sun's light could cross in a few hours. A black hole is not, as it is sometimes imagined, a void in space, a hole through which things fall into nothing. It is a region of such extreme gravitational density that not even light, once it crosses a certain boundary, can escape. That boundary is called the event horizon. Beyond it, the rules of space and time that govern everything we experience break down into territory we do not yet fully understand. Sagittarius A star is, by the standards of supermassive black holes, relatively quiet. In other galaxies, similar objects are actively consuming enormous quantities of material, surrounding themselves with glowing disks of superheated gas, shooting jets of energy thousands of light years outward. These are called active galactic nuclei, quasars. Some are among the brightest objects in the visible universe. Our galactic center is not doing this. It is calm. Occasionally it produces small flares, brief brightenings detected in X-ray and infrared. But mostly it sits at the center of the galaxy in a kind of deep, patient stillness. It holds the galaxy together. Its gravity, and the collective gravity of everything that surrounds it, is what gives the Milky Way its structure. Without it, without gravity, the galaxy would not be a galaxy at all. Just scattered stars drifting without relation to one another through the vastness. The spiral arms of the Milky Way, those graceful curves that make the galaxy so recognizable in images, are not permanent features in the way a riverbank is permanent. They are density waves, patterns of slightly higher concentration that rotate through the disk, encouraging the gas and dust within them to compress, triggering star formation, then moving on. Stars form more abundantly within the arms. They light them up from the inside. And then, over millions of years, those stars drift out of the arm that gave them birth, spreading into the spaces between. The arms are not so much structures as they are rhythms, travelling patterns of compression, like the rings that spread outward from a stone dropped in still water, except that these rings rotate slowly and persist for billions of years. How many arms the Milky Way has is, remarkably, still not entirely settled. From our vantage point deep within the disk, seeing the whole structure clearly is difficult. Dust obscures distant regions. The arms themselves are not perfectly symmetrical. They branch, they thin, they thicken. Some estimates point to 4 major arms. Others suggest the picture is more irregular, more asymmetric, more alive with variation than a neat spiral illustration would suggest. We are inside the image we are trying to see. We are looking at the forest from within the trees. Outside the visible disk, beyond the spiral arms, beyond the thin outer regions of the galaxy, lies a structure called the halo. It is enormous, vastly larger in some respects than the disk itself, and it contains things that the disk does not. Globular clusters for one. These are ancient, densely packed spherical gatherings of stars, some containing hundreds of thousands of individual stars bound together by their mutual gravity, orbiting the Milky Way in long, looping paths that carry them far above and below the plane of the disk. The stars within globular clusters are very old. Some of the oldest known stars anywhere are found in them. Their light carries a kind of age that is hard to fully imagine. Stars that were already ancient when the sun was forming. Stars whose light has travelled longer than the Earth has existed. In the halo, time feels different. The stars there do not share the rhythm of the disk. They move on independent orbits, inherited from whatever smaller galaxies they originally belonged to, before those galaxies were drawn in and dismantled by the Milky Way's gravity. Some halo stars move in the same direction as the disk. Others trace retrograde paths, orbiting opposite to the galaxy's main rotation. Their reversed motion is a kind of quiet signature, a memory of elsewhere, a record of travels that ended in absorption. The Milky Way has not grown to its current size alone. It has consumed. Over billions of years, smaller galaxies, dwarf galaxies, satellite galaxies, faint companions drifting too close, have been drawn in by the Milky Way's gravity. Their stars have been pulled free of their original shapes, stretched into long streams that wrap around the disk, and eventually integrated into the larger structure. Astronomers call these structures tidal streams, and they can still be found. By tracking the motions and chemical compositions of stars in the halo, researchers have traced the outlines of galaxies that no longer exist. As galaxies, their identity dissolved, their stars scattered, but their paths still readable in the data. One companion galaxy, known as the Sagittarius Dwarf, is still in the process of being absorbed right now. It has already passed through the disk of the Milky Way multiple times, each pass pulling it apart further, scattering its stars into an enormous stream that loops around the galaxy. It no longer resembles a coherent galaxy, but its stars remain, and their paths record what it was. This is how the Milky Way has grown, quietly, over enormous timescales, through the slow gravitational unraveling of smaller things. Not destruction exactly, more like assimilation. The stars do not vanish, they simply join a larger story. Among the most astonishing things in the Milky Way are the stars that leave it entirely. These are called hypervelocity stars, and their name describes their nature precisely. They move at speeds so extreme that the galaxy's gravity cannot hold them. They travel outward past the disk, past the halo, and into the intergalactic spaces between galaxies, never to return. How does a star reach such speeds? The leading explanation involves the supermassive black hole at the galactic center, and a particular configuration of binary stars, pairs of stars orbiting one another. When such a pair passes close enough to Sagittarius A star, the black hole's gravity can disrupt the binary. One star is captured by the black hole. The other is flung outward at tremendous velocity. The gravitational energy of the interaction transferred entirely to its motion. The star that escapes travels alone into the dark. No stellar neighbors, no galaxy to belong to. Just momentum and space and the slow cooling of its own light as it recedes forever. There is something haunting about that image. A star born in community, nurtured in a nebula alongside thousands of others, spending most of its existence in the familiar company of the galactic disk, and then, in a single catastrophic encounter, ejected, sent beyond reach, traveling toward a future with no destination. And yet it still burns. It still fuses hydrogen and shines. Its existence continues, unchanged, even in exile. Let us move now towards something a little closer to home. The chemical history of the galaxy is written in the stars themselves. Every atom heavier than hydrogen and helium was made inside a star. Carbon, nitrogen, oxygen, silicon, iron, all of it assembled through nuclear fusion within stellar interiors, or scattered outward in the final explosions of dying massive stars. When a massive star ends its life as a supernova, a violent, brilliant collapse and explosion, it seeds the surrounding space with the elements it built over its lifetime. That material becomes part of the interstellar medium. Eventually, it is incorporated into new molecular clouds, into new stellar nurseries, into new stars and new planets. The iron in your blood was forged in a stellar core. The calcium in your bones was scattered by an ancient supernova. The oxygen you are breathing right now was produced inside stars that no longer exist and distributed across space billions of years before the sun ever formed. You are not separate from the galaxy. You are made of it. You are, in the most literal chemical sense, our arrangement of material that was once inside a star. That is not a metaphor. It is chemistry. Over time, as generation after generation of stars has formed and died and scattered their material outward, the chemical composition of the galaxy has changed. The earliest stars contained almost nothing but hydrogen and helium. The universe had not yet had time to build anything heavier. But each generation of dying stars enriched the interstellar, added more complexity, more variety, more of the elements that make possible the chemistry of planets and oceans and living things. The Sun, being a middle-aged star, formed from material already enriched by several previous generations of stellar evolution. It is, in the language astronomers use, a metal-rich star, meaning it contains measurable quantities of elements heavier than helium. And that enrichment is part of why the planets that formed alongside its rocky and varied and capable of supporting liquid water, and the long, slow processes of chemistry that eventually produce life. The Milky Way is not symmetric. Despite the graceful spiral images, the smooth arms, the glowing center, the even distribution of light, the actual galaxy is subtly lopsided, gently warped, slightly off-center in its own halo. The disk itself is not perfectly flat. It curves upward on one side and downward on the other, like the brim of a hat that has been gently bent. This warping is visible in the distribution of stars in the outer disk, and astronomers believe it is caused by the gravitational influence of the Large and Small Magellanic Clouds, two companion galaxies that orbit the Milky Way and whose gravity subtly tugs at its edges. One side of the disk is thicker than the other. The spiral arms are not evenly matched in brightness or extent. The halo itself is not quite centered on the disk. None of this makes the galaxy less beautiful. If anything, it makes it more true to what complex, lived-in things actually are. Perfectly symmetric spirals exist in diagrams. Real galaxies have history written into their shapes. The accumulated record of every gravitational interaction, every merger, every tidal force that has nudged them over billions of years. The lopsidedness of the Milky Way is the same as the asymmetry in every old, experienced, interesting face. It is the shape of having been through things. Among the tools astronomers use to map the galaxy, certain kinds of stars function as reliable distance markers. Their brightness follows predictable patterns. It cycles up and down with a period directly related to their true luminosity. By measuring how quickly a star brightens and dims, and comparing that to how bright it appears from Earth, astronomers can calculate its distance with precision. These pulsing stars, called variable stars, or more specifically Cepheids and RR Lyrae stars, have allowed scientists to build three-dimensional maps of the Milky Way, piece by piece. They are scattered throughout the disk and the halo, blinking their distances like patient signals. They are, in a sense, the galaxy's own coordinate system. Nature's version of mile markers set into the fabric of the spiral arms, glowing steadily enough to be measured, varying predictably enough to be trusted. Without them, the scale of what we inhabit would be much harder to determine. The galaxy would remain, to our instruments, a flat projection, bright in some directions, dark in others, but without depth. With them, we begin to perceive the three dimensions of our home. In recent years, a single mission has done more to change our understanding of the Milky Way than almost any other project in the history of astronomy. The Gaia spacecraft, launched by the European Space Agency, is doing something that seems almost impossibly ambitious, measuring the precise positions and motions of more than 2 billion individual stars within the galaxy. Not just where they are now, but where they are going, how fast, In what direction? With what variation? From this data, vast, intricate, continually updated, astronomers are building a picture of the Milky Way in 4 dimensions, including time. They can trace where stars came from. They can identify groups of stars that share a common origin, even though they are now scattered widely across the disk. They can map the tidal streams of dissolved galaxies. They can measure the warping of the disk, the shape of the halo, the precise orbit of the Sun around the galactic center. Every new release of Gaia data brings a new wave of discoveries. The galaxy becomes a little more sharply focused, and in becoming more known, it reveals how much more there is still to learn. Science, at its best, works this way. Every answer contains several new questions. Every measurement sharpens the next question's definition. We do not move toward a final answer so much as toward an ever more detailed appreciation of the complexity we inhabit. Now let us settle into something quieter. The Milky Way, for all its stars and clouds and spiral arms and hidden center, is mostly empty. The distances between stars are so enormous that if you were to travel from the Sun to the nearest neighboring star at the speed of a commercial airplane, it would take approximately 4 million years to arrive. The nearest star system, Alpha Centauri, a triple star grouping roughly 4¼ light years away, in the context of the galaxy, essentially next door. And yet even this neighbour is separated from us by a void so vast that no human technology has ever crossed it, and none currently being developed would cross it within many lifetimes. Space is not full of things. It is mostly the absence of things. And the things within it, the stars, the clouds, the planets, are separated by distances that our minds were not built to hold. This is not a failure of imagination. It is simply that our minds evolved to navigate a world of trees and water and other people. The scale of the galaxy is not something evolution prepared us to feel intuitively. It can only be approached obliquely, through numbers and metaphors, and the slow accumulation of time spent considering it. Some of the oldest objects in the Milky Way carry the deepest histories. White dwarfs, the cooling remnants of stars like our Sun, stripped of their outer layers and left to slowly radiate their remaining heat into space, are among the most ancient things we have detected in the halo. Some of these objects formed when the galaxy was very young, before the thin disk had fully assembled itself, when the Milky Way was a more chaotic, less organized system, still in the process of becoming what it would be. These ancient white dwarfs have been cooling for billions of years. They are faint and dim, nearly invisible against the dark, but they can be found with sensitive instruments, and their temperatures tell us roughly how long they have been cooling, which tells us when they formed. They are not dramatic objects. They do not pulse or explode or shoot jets of material into space. They simply cool, slowly, over timescales longer than the Earth has existed. There is something I find quietly moving about that. A star that lived its full life before our sun was born, that fused and burned and eventually shed its outer layers in a slow, expanding cloud of gas, and then settled into cooling silence. That star is still there, still present, still detectably warm by tiny fractions of a degree, billions of years later. The past does not entirely vanish. It dims, but it persists. Let us think for a moment about what it means to be inside the thing you are trying to understand. Because of our location within the Milky Way's disk, we cannot see the galaxy from outside. We see it edge on from within, a band of concentrated starlight crossing the sky, appearing from Earth as a river of faint luminosity, stretching from horizon to horizon on a dark night. That band is the galaxy's plane, seen from the inside. We are looking along the disk's length, through its greatest depth of stars, and the accumulated light of billions of stars too distant to resolve individually blurs together into that soft, hazy band. For most of human history, no one knew what the Milky Way was. It looked like a cloud, like a river, like a wound in the sky in some traditions. It was beautiful and strange and utterly mysterious. It was only in the last few centuries, beginning with Galileo's telescope, which resolved it into individual stars, and continuing through the work of generations of patient astronomers, that we understood we were looking at a structure, our structure, the inside view of our own home. And there is something deeply affecting about that moment of recognition. When you look at the Milky Way on a dark night, you are not looking out at something distant and separate. You are looking into the galaxy you are part of. You are inside the image. As you grow quieter now, let yourself feel the scale of what you are resting within. The Milky Way has existed for longer than the Earth by many billions of years. It has been turning slowly through space since long before the sun condensed from its birth cloud, before the planets formed, before the chemistry of living things began to unfold in the shallow oceans of a young world. In all that time, the galaxy has turned roughly 50 to 60 times. A slow, patient revolution. The same forces operating over the same enormous timescales, producing the slow accretion of complexity that eventually, in one quiet corner of one spiral arm, made space for all of this. You are resting in the galaxy right now, not metaphorically, literally. The planet beneath you is part of the solar system, which is part of the Milky Way, which is itself part of a larger cluster of galaxies, which is part of a supercluster, which is embedded in a vast cosmic web of matter and energy that stretches across the observable universe. You are not separate from any of this. You are an expression of it, made from its material, warmed by one of its stars, cradled in the gravity of one of its spiral arms. And right now, you are resting exactly where you belong. There are stars in the Milky Way that are truly solitary. Not in the way that most stars are solitary, surrounded by light years of empty space, but still part of the general community of the disk, but genuinely, permanently alone. These are the hypervelocity stars we mentioned earlier, those ejected from the galaxy's center. But there are others too, stars that formed in isolation, far from the dense clouds where most of their kind are born. Stars in the outer halo that may never have passed close to another star in their entire existence. Stars that orbit the galaxy on paths so wide and so tilted that they spend most of their lives in the remote emptiness above and below the disk. They shine the same. They fuse the same hydrogen into the same helium, produce the same light. Whatever company they are in, or are not in, makes no difference to their internal chemistry. A star shines because of what it is, not because of who is watching. That is true of many things, perhaps. The future of the Milky Way is already written, in a sense, at least in its broad strokes. In approximately 4.5 billion years, the same span of time that has passed since the Earth formed, a neighbouring galaxy will arrive, Andromeda, another great spiral, somewhat larger than our own, currently moving toward us at nearly 110 kilometers per second. It is, in cosmic terms, not especially fast. And 4.5 billion years is a very long time, but the trajectory is clear and the collision is coming. When it happens, it will not be violent in the way collisions we are familiar with. The stars in both galaxies are too far apart to crash into one another directly. The vast majority of individual stars will simply pass each other by, their paths altered by gravity, drawn into new orbits, scattered into elongated tidal streams. But the shapes of both galaxies will be fundamentally changed. The spiral arms will unwind. The disks will buckle and stretch. Long threads of stars will extend outward in great arching tails. And over hundreds of millions of years, the two galaxies will pass through each other, separate slightly, return, and eventually merge into a single larger structure, an elliptical galaxy, smooth and rounded, its spiral character dissolved. Our distant descendants, if there are any, and if they are still here, will live in that merged galaxy. They will look out at a night sky transformed beyond recognition. Different stars nearby, different concentrations of light in different directions. Perhaps the two former black holes, now spiraling toward each other, will have merged, releasing a burst of gravitational waves that would ripple through the fabric of space-time itself. The galaxy is not permanent. It is a stage in a longer process, a structure that forms, grows, merges and transforms over timescales that dwarf even the current age of the universe. Let your breathing slow a little more now. Let the thoughts become less sharp, less sequential. Let them drift the way stars drift, not randomly exactly, but following the quiet pull of whatever is nearest to them. The Milky Way is a place of extraordinary patience. Nothing in it hurries. Stars form over millions of years. They live for billions. They die in events measured over thousands of years or over days, but even the fastest things in the galaxy take minutes to communicate across the solar system, years to communicate across interstellar space. In the context of that patience, the urgency of any single day becomes very small, never meaningless, but small, held within something immeasurably larger that is not troubled by what troubles us. The galaxy does not worry, it turns. Stars do not struggle toward their own light. They simply burn, following the physics that built them, expressing their nature continuously and without doubt. There is something in that if you want to find it. Consider for a moment the journey light takes to reach us from distant parts of the Milky Way. When you observe a star at the far edge of the galaxy, through a telescope or simply by imagining it, the light you are seeing left that star long ago. For a star near the opposite edge of the disk, perhaps 80 light years away, the light you receive tonight departed approximately 80,000 years ago. At that time, the Earth was home to early modern humans. Neanderthals still shared the planet with us. The most sophisticated tools were made of stone. The civilizations, the writing systems, the cities, the centuries of recorded history, all of this lay in a future that those light-traveling photons had no way of knowing would occur. That light left a star before any of it happened, and tonight it arrives. Every time you look at the night sky, you are receiving messages from different depths of the past simultaneously. The nearby star is seen as it was a few years ago. The distant smudge of a galaxy is seen as it was millions of years ago. The cosmic microwave background, the faint afterglow of the Big Bang, still detectable in every direction, is seen as it was roughly 13.5 billion years ago. The sky is not a window into space. It is a window into time. And you are looking through it right now from this small, warm place. Let your eyes grow heavy if they want to. Let the words become background. Let the ideas settle into something softer, less argument, less structure, more texture. The way the sky looks like when you look at it not to identify anything, but simply to be present with it. Dark matter is one of the great mysteries still carried within the Milky Way. It is called dark not because it is somehow frightening or negative, but simply because it does not emit or reflect or absorb light in any way that our instruments can detect. It reveals itself only through gravity, through its effect on the motion of visible things. And the evidence for its existence is persuasive. The outer parts of the Milky Way orbit faster than the center they should, given only the visible mass of stars and gas. If visible matter were all there was, outer stars should orbit more slowly, the way planets in the outer solar system orbit the sun more slowly than inner planets do. But they don't. They move faster than gravity alone from visible matter would allow. Something else must be providing additional gravitational pull. Something massive, distributed throughout and around the galaxy, but invisible to our instruments. Astronomers call it dark matter. They believe it makes up perhaps 25% of the total energy content of the universe. In the Milky Way, it forms a vast halo around the visible disk, extending far beyond the stars, providing the gravitational scaffold within which the galaxy sits. What dark matter actually is remains one of the most important unsolved problems in physics. Candidates have been proposed, experiments have been designed, but as of now, it has never been directly detected, only inferred. The galaxy contains more mystery than knowledge. And that is not a failing. That is an invitation. There are stellar remnants in the galaxy, besides white dwarfs, that mark the endings of more massive stars. When a star much more massive than the Sun reaches the end of its fuel supply, the result is more dramatic. The core collapses. In the collapse, the core's material is compressed so rapidly and so intensely that the outer layers of the star rebound in a catastrophic explosion, a supernova, that for a brief period can outshine an entire galaxy. What remains after the explosion depends on how much mass the core contained. For some stars, the remnant is a neutron star, an object nearly the mass of the Sun, compressed into a sphere, perhaps 20 kilometers across. The density is almost incomprehensible. A teaspoon of neutron star material would weigh as much as Mount Everest. Some neutron stars rotate very rapidly. As they do, they emit beams of radiation from their magnetic poles. If those beams sweep across the Earth as the star rotates, we detect regular pulses of radio waves or X-rays. These are pulsars, some of the most precise timekeepers in the universe, their pulses more regular than any clock we have built. For the most massive stellar cores, the remnant is a black hole. Not a supermassive black hole, like the one at the galactic center, but a stellar mass black hole. Still enormously dense, still surrounded by an event horizon, still swallowing light. The Milky Way contains an estimated 100 million stellar mass black holes, distributed throughout the discant halo. Most are invisible, detectable only when they interact with nearby material, drawing gas from a companion star, for instance, heating it until it emits X-rays that our instruments can detect. 100 million black holes scattered through our home galaxy, and we can barely find any of them. Slow down now. Let the images become hazier. Think about the night sky above you, even if you cannot see it right now. The faint dusting of stars visible on a clear night. Each one a sun. Each one burning with the same basic process that warms your world. Each one potentially surrounded by planets. In the last few decades, astronomers have confirmed that planets are not rare exceptions. They are the norm. Nearly every star appears to have at least one planet. Many have several. Rocky worlds, gas giants, ice-covered moons with liquid water beneath them. The variety of planetary environments in the galaxy is enormous. This means the Milky Way contains, at minimum, hundreds of billions of planets, possibly 1 trillion or more when smaller objects are included. Whether any of them harbour life, whether the chemistry that unfolded on Earth has unfolded elsewhere, in other oceans, under other suns, remains unknown. The distances are so vast that communication between civilizations, if they exist, would span centuries or millennia at the speed of light. Even detecting signs of life from here would require instruments far beyond what we currently have. But the possibility is real. The conditions exist in many places. The elements that life requires are common. The timescales are enormous. And perhaps that is enough for now. Not certainty, just possibility. The quiet, open-ended sense that the galaxy is not empty in the ways that matter most. Let your awareness settle lower, into your body, into the warmth of wherever you are resting. There is a kind of mathematics at the heart of everything the galaxy does. Gravity follows precise equations. Light behaves according to rules. Quantum mechanics governs how atoms fuse inside stellar cores. The large and the small, the ancient and the forming, all of it follows patterns that human minds have been able to slowly, partially, approximately describe. This is one of the stranger facts about the universe, that it is comprehensible at all. That a mind built to navigate social situations and find food in a forest can, given enough time and enough tools and enough collaboration across generations, work out the equations governing the behavior of matter and energy at the largest and smallest scales. Why should the universe be describable in mathematics? Why should its patterns be the kind of patterns that minds like ours can approach? No one knows. It remains one of the unexplained things. but it is the foundation of everything we call science, and it seems to be reliably true. The universe behaves consistently. Its rules do not change from place to place or moment to moment. And because of that, knowledge accumulates, discoveries hold. One generation's observations become the next generation's starting point. The Milky Way is not just beautiful, it is intelligible. And that intelligibility is itself a kind of gift. The stars in the Milky Way are not all alike. There are blue stars, burning at temperatures so extreme that their light carries mostly ultraviolet radiation. These are among the most massive stars in the galaxy, and their lives are brief, tens of millions of years at most, before they exhaust their fuel and collapse. In astronomical terms, they live fast and die young. There are red dwarf stars, far smaller and cooler than the Sun, burning their hydrogen so slowly and so efficiently that they can persist for tens of billions, even hundreds of billions of years. Since the universe is only about 13.5 billion years old, no red dwarf has ever died of old age. All that have ever formed are still burning. There are binary stars, pairs of stars orbiting one another, some close enough that they share material, others separated by distances that barely affect their individual evolution. There are triple systems, quadruple systems, clusters of young stars still embedded in the nebula of their birth. Ancient solitary stars on eccentric halo orbits, travelling paths so tilted and elongated that they spend much of their time far from the plane of the disk. The galaxy is not a uniform collection. It is diverse in exactly the way you might expect something to be diverse after billions of years of formation, evolution, interaction, and accumulation. Each star a distinct history, each system a distinct chemistry and arrangement. Within that diversity, our sun sits quietly, ordinary, steady, reliable. A middle-aged star in a comfortable part of the galaxy, circled by a family of planets, one of which has spent 4 billion years growing complex enough to wonder about the galaxy that holds it. Let your thoughts become slow rivers now. Let them move without rushing anywhere. Let the images come and go. Stars, dust, distant light. The quiet center of the galaxy. The wide, cold halo. The spiral arms turning through their long, slow dance. You are somewhere inside all of this. The same atoms that were forged in stellar fires, scattered in supernova, gathered into clouds, condensed into new stars, and eventually assembled into the rocky material of this planet. Those same atoms are now arranged into you, into your specific shape, your specific chemistry, your specific capacity for thought and rest and wonder. You are not made of the universe the way a box is made of wood, as something separate from its origin. You are made of it the way a wave is made of the ocean. You are a temporary, local, intricate configuration of material that the universe has been working with since the beginning. And right now, that configuration is resting. The part of the universe that is you is resting. And the rest of it is still out there, still turning, still forming, still burning, still drifting through its vast, patient processes. And it will be there when you wake up. Nothing requires your attention tonight. The galaxy does not need you to hold it together. It has been doing this for 13 billion years and is entirely capable of continuing without your wakefulness. Let go of whatever you are still holding. Let the darkness behind your eyes be the darkness of space, deep and full, not empty, never actually empty, but quiet, holding in all its vast extent more than can be seen or named. The light of billions of stars is traveling through that darkness right now. Some of it will eventually reach a telescope. Some of it will miss every particle of matter it passes and travel on indefinitely. And some small fraction of it, falling on leaves and oceans and the faces of living things, will be absorbed and transformed into something new. Light is patient in that way. It travels as long as it needs to. You have nowhere to travel tonight. You are already where you are going. The center of the Milky Way glows in wavelengths we cannot see with our eyes. Infrared light, warm and invisible. Radio waves, long and slow. X-rays, sharp and energetic. The galactic center speaks in frequencies our bodies were not built to hear. And yet we know it is there. We have inferred its presence, measured its influence, imaged it indirectly. We have watched stars near the center orbit something massive and invisible, tracing tight, fast ellipses around a point in space that emits no visible light. The black hole does not need to announce itself. Its presence is evident in the behavior of everything around it. There is something I find quietly profound about that. Not all presences are visible. Not all influences allowed. Some things make themselves known only through the effects they have on what surrounds them, through the way nearby things move, through the paths they bend, through the orbits they shape. The most important things in any system are sometimes exactly like that. Let the numbers soften now. Let the scale dissolve into something more personal. You are a small, warm thing in a galaxy 100,000 light years across. You are one of approximately 8 billion humans on a planet that is one of several 100 billion in just this one galaxy. Your galaxy is one of hundreds of billions in the observable universe. These numbers are not meant to diminish you. They are the context in which you exist. Within that context, the fact that you are here, alive, conscious, capable of resting after a long day, capable of wondering about the stars, is not a small thing. It is, given the simplicity of what the universe started with, an astonishing elaboration. Hydrogen and helium, gravity and time. From those simple ingredients, everything, including whatever you are thinking about right now, as your thoughts grow slower and softer and begin to sink towards sleep. The disk of the Milky Way is roughly 1,000 light years thick in its main structure. The halo extends perhaps 10 times farther in all directions. The dark matter halo, if the estimates are correct, may extend much farther still, perhaps several 100,000 light years from the center. We are embedded in a structure whose full extent we are still working to determine. Its edges are not sharp. They fade into the surrounding intergalactic space gradually. Fewer stars, thinner gas, weaker gravity, until eventually the influence of the Milky Way gives way to the emptiness between galaxies, punctuated only by the occasional wandering star or the distant light of a neighboring galaxy. And even that emptiness is not nothing. The space between galaxies carries its own faint gas, extraordinarily thin, millions of times less dense than the gas inside galaxies, but present nonetheless. A vast warm network of filaments stretching between galaxy clusters, the remnant architecture of how the large-scale structure of the universe first assembled. Everything connects to everything. At different scales, with different densities, but without true gaps. The universe is not a collection of separate things. It is one deeply interconnected system, varying enormously in concentration and character from place to place, but continuous. You are not separate from it. You are continuous with it. A dense, warm, complicated concentration of its matter, temporarily organized into the specific pattern that is you. Breathe. The galaxy is breathing too, in its own way. Great clouds of gas slowly cooling and collapsing into new stars. Stellar winds pushing material outward, enriching the spaces between. Supernova driving shockwaves through the interstellar medium, compressing gas, triggering new rounds of star formation. Energy cycling through matter and back again, over and over, in processes that began before the sun was born and will continue long after it is gone. It is not a machine, It is more alive than that, more responsive, more self-organizing, more generative. Not in the way a living thing is alive, not sensing or deciding or choosing, but in the way a complex dynamic system is alive, always changing, always producing something new from what has come before. Resting within that, this planet, this room, this body is a form of participation. You are not apart from the galaxy's ongoing process. You are an expression of it. What it has become, locally and temporarily, here. Rest is part of the process. Rest is where energy is conserved and structure is maintained. Rest is not absence. It is a kind of presence, quiet, still, but fully here. The stars above you right now, even if clouds are covering them, even if city light is drowning them, are still there. They do not require darkness to exist. They burn continuously. Their light passes through cloud and atmosphere and the walls of the room you are in unimpeded, though in wavelengths too long or too energetic for our eyes to see it directly. The galaxy surrounds you, not as a distant thing visible only from mountaintops on moonless nights, but as the actual structure you are inside. The gravitational field of the Milky Way extends through this room. The dark matter halo permeates this space. Every second, neutrinos produced in the sun's core pass through the Earth and through you by the billions, utterly without effect, utterly without notice. You are bathed in the galaxy constantly. You are held by it. Its gravity is in the floor beneath you, the atmosphere above you, the path of the planet through space. You are never not in it. Let your thoughts lose their edges. Let them become general and soft and warm, the way starlight blurs when it passes through a thick atmosphere. You have travelled far tonight, across scales of space and time that most conscious beings will never contemplate. You have held, briefly and lightly, some of the largest truths known to human inquiry. And now you can set them down. They will still be true tomorrow. The galaxy will still be there. The stars will not have moved measurably. The questions will still be open. And you will be there too, rested. Return to yourself after this necessary journey into rest. The great thing about the universe is that it does not require understanding. It does not need to be comprehended in order to continue being what it is. You can know nothing about it and still be within it, held by its gravity, warmed by its light, composed of its matter. You have already arrived. You are already home. Let the last thoughts come quietly. 100,000 light years of stars, 200 billion suns at least, hundreds of billions of planets circling them, ancient clusters in the halo, each holding hundreds of thousands of stars that have been orbiting together for longer than the Earth has existed. A supermassive black hole at the center, silent and patient. Tidal streams of dissolved galaxies, still tracing their long arcs through the disk. Hypervelocity stars on one-way journeys into the dark. Molecular clouds in the spiral arms, assembling new suns from ancient material. White dwarfs cooling in the outer halo, their light carrying memories of a universe that existed before this one was organized. All of it turning, all of it patient, all of it enormous. And here, in some quiet corner of the Orion Arm, a minor spiral feature between two larger arms, a backwater of the galaxy by any measure, one small star, one warm planet, one species looking upward, slowly working out where it is. And tonight, one person resting, part of all of it, return to stillness after a long day, breathing slowly, sinking into sleep, carried gently through the dark by a planet moving through a galaxy that has been turning without interruption for 13 billion years. You are exactly where you belong. Sleep well.